Here we go, part two. Let's talk about functions again. So let's talk about something called function notation. This is how we write functions. Okay, so now we have some old stuff. Okay, old. You've done in the past a line. So let's make a line. Y equals 2x plus 1. Okay, you should recognize that's a line. And we just talked about line. A line is called a linear function. So now this 2, you should remember, is called a slope. And this, the b value in the back, is called a y-intercept. Now, the y values depend on what x value you plug in. So if I plug in, like a 3, you go 2 times 3, 6 plus 1, the y value is 7. So the y value depends on what you plug in for x. So let's talk about the new way now. Now the new way is called function notation. So we're going to use function notation. And here's function notation, ready? Instead of y, we say f of x, f for function. And I'll use the same function, 2x plus 1. And how we say this is f of x. This is a function of x. Now what you have to know is look at the positioning, the pattern. If you see f of x, so if you see f of x, you need to know f of x just means y values. Now, f of x is the most common. F of x is the most common. Sometimes you might see other ones too, such as g of x, excuse me, h of x. H of x is pretty common also, but f of x is the most common. F of x is the most common. So let's do something here. And what we could do now with this is we'll call evaluate a function. So we have the function. Let's stick with f of x equals 2x plus 1. And they won't say x equals 2, tell me why. This is how they would say it. They would say, what is f of 2? Now what this means is, it means plug in x equals 2. That's what that means. So now you go over to your function, and wherever you say x, you plug in 2. So it'd be 2 times 2 plus 1. And then you do it. If you can do it, do it. 2 times 2 is 4 plus 1 equals 5. So f of 2 is 5. If this was a point, the x value is 2, the y value is 5. That would be the point. Let's try it again. F of 1. So try it out. Two times 1 plus 1 is 3. If this was a point, it would be 1, 3. How about negatives? F of negative 3. Negative. Two times negative 3, negative 6 plus 1, negative 5. And that's how you evaluate a function. You just plug in and do what it says. So how do they make it harder? Well, of course they make it harder. Let's use graphs. So that's going to be a little tricky now. So I'm going to draw a graph. Trying to draw a graph. So 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to do it by fours. And I'm just going to put a couple of key points here. So I'm going to hit here. This would be here. Do that here. So this would be a straight line. There we go this way. And then this would be a straight line across. That's a -1. And let's say like this. And I'm calling this f of x. So it's called the function. Well, how do I know it's a function? Well, if I did a vertical line test up and down, the x values don't repeat. This flat part's okay because it doesn't repeat on the x. So now, looking at the function, looking at the graph, they would go like this. Find f of, let's say, 2. And what this means is, where is the graph at x equals 2? So what you do is you go to the 2, hit the graph. Well, it just happens to be right there. So if they say, what's f of 2? The answer is 0. It would be the point 2, 0. Let's try it again. F of 3. So this is saying x is 3. Remember, x is on the inside. Go to 3. Hit the graph. I'm going to hit the graph. It's up in the air. And that would be at point 1, 2. So it would be 2. Why don't you try f of 0? F of -4. Zero. Go to x is 0. Go down, hit the graph. The answer is -2. F of -4. 1, 2, 3, 4. Right here at 0. And that's pretty much how to evaluate a function using graphs. So hopefully this helps. And that's pretty much it. Thank you very much.